Hi devs, welcome to another video. So today we'll be looking at question number 649, Dota2 Senate, which is part of the Lead 75 series. Now this question is quite long. I would like to just summarize things down. In a nutshell, you have a Senate which is made out of many people. We have two parties. One is called the Radiants and the other one is called the Dyers. So for short, they are called R and D. You are given a string of the members of the Senate. So they could be something like RD, which basically means the Senate is made out of two people, or RDD, or any other string that has like a permutation or combination of R and Ds. Now, how this works is, let's go to the whiteboard quickly. Okay, so how this works is like if we have a Senate of R, D, D, R, and R, for example, each member has two choices. So they can either, first thing they can do is ban someone from the other party, and the second thing they can do is vote. Now what we're being told is that this can go on indefinitely until there is some sort of a conclusion, right? So that means that round one, if everyone's voting, everyone will obviously vote for their own party, right? So if round one starts and then the first guy votes for R, second guy votes for D, third guy votes for D, fourth for R, and then last one for R. So that means that R has 3 votes, D has 2 votes, so obviously R won, right? But if only it was that simple. What most people decide to do is that they want to start banning other people. So the first round kind of starts with the first character, so R, right? So here's where we're starting, and then R can go ahead and either vote or ban. But then since we are assuming that everyone's going to be playing this smart, so they're going to be banning the opposition party. So R goes in and they decide that I'm going to ban D, right? And then the next person to vote will be D. D decides that they're going to go ahead and ban R, right? Now they could choose to ban either the first R, the nearest R, or the last R, right? Now ideally we probably want to ban the nearest R, right? So the nearest opposition party. So D would go ahead and ban R, and then it's this R's turn, right? R would go ahead and ban D, right? So the next D is once we loop around, so the next D is actually here, right? So R would go ahead and ban this guy, and then the next person to vote will be the first R, and then R would vote for R, right? And therefore the Radiants have won the elections. I hope that makes sense. So in theory, this question seems to be relatively simple, but I would like to give props to LeetCode here, because it's only after watching his video is when this whole logic kind of made sense to me. So the approach that I'm going to be using is quite similar to what LeetCode has suggested, which is using two queues. How queues work usually is you would have a queue that has got data in it. So it will have 1, 2, 3, 4, right? And we can insert to the back, right? And we can remove from the front, right? So every time we want to get somebody who's voting, we would probably pop that guy off, right? Let them do their voting business. And then if they haven't been banned, then we probably want to insert it at the back, insert that person at the back, right? And this could go on indefinitely until we have a solution, right? Or until one queue is empty. So since JavaScript doesn't have a queue data structure built in, probably the best way of doing it would be using an array and using the shift and push operations. How the shift operation usually works is if we have our data 1, 2, 3, 4, right? And then what we want to do is we want to shift this guy out, right? That means our data will now look like 2, 3, 4, right? So it's an O of N operation in the sense that we are moving everything, we're shifting all the data one slot towards the left, right? And then once this guy is done voting and we want to reinsert them back, that will be a push operation, which is an O of 1 operation. So unfortunately with JavaScript and the shift operation, we have to keep this in mind that this will be an O of N operation. So ideally what we would like to do is use some sort of like a queue data structure. So let's move on to the code. Let's see how this works. So the first thing that I want to do is probably like store the length of the Senate. This will just help us in getting an offset value. So const offset. This will be the length of the Senate. And then we want to maintain two queues or two arrays in our case. So we will have the radiance queue and then the dyers queue. How we're going to populate this is going to be using their positions, right? So we know that who's going to vote first. I hope that makes sense. So we can just do a for loop. I less than Senate dot length and I plus plus. What we want to do is we want to check if the current position has got an R in it, then we want to add them to the radiance dot push, and we're going to push the position that it's at. Otherwise we're going to assume that it's going to be a dyer, so we'll push it to the dyers array, right? We have two arrays that have got all the positions of the members, while both of the arrays have got people who have not voted yet, right? Or who haven't been banned yet. We want to go through this loop. So we can do a while loop of radiance dot length is greater than 0 and dyers dot length is greater than 0. Now what do we want to do over here? So first thing that we want to do is we want to get the first people who need to vote, right? So let's just say that we want to get the first radiant that needs to vote and the first dyer that needs to vote. So the first radiant would be radiance.shift. That will give me the first radiant, and dyers would be dyers.shift. That will give me the first dyer that needs to vote. If the dyer comes before the radiant, right? So if dyer comes before the radiant, right, then what we want to do is we want to ban the radiant, right? So how we're going to ban in this case is since we have already shifted them out of the array, so we're not going to put them back. But then we want to put the dyer back, right? So we will put the dyer back, dyers push, and then here's where the offset kind of comes into handy. So we want to take the current position that they're at, and we're going to add the offset, right? And if that's not the case, so else, so if this case is where the radiant comes before the dyer, we want to do the opposite. So we want to take the radiance and push the current position plus the offset, right? And after all of this is done, so we have gone through the loop, we have gone through the loop multiple times, one of the arrays is going to be empty. We're going to return whichever array is not empty. So if let's just say radians dot length is greater than 0, then we want to return the string radiant. Otherwise, we're going to return the string dire, right? So hopefully that makes sense. Let's try and run this. That works. Let's try and submit it. Oh, well, I'm actually surprised at how relatively efficient this solution is, given that we are doing shifts. Okay, with that, I guess, thank you so much for watching this video, and thank you again for giving so much support to this series, and hopefully we'll catch you in the new one. Cheers.